Hey guys, welcome to ThinkX Academy. In this video, we are going to study about the sequential circuits. So far, we have already covered the digital logic circuits, in which we have discussed about the logic gates like AND, OR, and exclusive OR, etc. Then we moved on to another step by making some combinations of these logic circuits, and then we obtained the combinational circuits like half adder and full adder. So now we are going to move to the sequential circuits which adds a new functionality, or you can say an advancement over the combinational circuit. So let's see what is this advancement. So in the sequential circuits, it's basically a combination So it's basically a combination of the combinational circuits, and enhancement is the storage element. So now in our circuits, we are going to include storage elements, and these storage elements are not used to store a huge data, but these are used to store a few bits. So I'm going to write here store for the purpose of storing bits. So now in this tutorial, we are going to study about sequential circuits, which adds a functionality of storing some bits. So the question arises here that why there is a need to store the bits, and that's where lies the functionality or the main essence of introducing sequential circuits in our computer system architecture. So let's understand what is the use of adding these storage elements. So let's take this operation, which is 7 plus 7. We have discussed about how we can use combinational circuits to actually perform this operation. First, we will convert them into the binary numbers here, or I will just write it in the center. So 7 plus 7. First, we are going to convert it into the binary numbers, which is 111 and 111. So at this point, we know that if we want to add these bits, we can make use of the combinational circuits. Half adder is used to add 2 bits, and since these 2 bits will give sum as 0 and 1 carry, then we will get 3 inputs, and we can use a full adder, which is a combination of 2 half adders, and then we can obtain the combinational circuit, or we can get the desired result here. Then what is the need of adding the storage elements? So the basic idea or the basic need of adding the storage elements is to store the previous outputs. So you can see that when you want to perform the addition operation to these 2 inputs, you can see that the operation at this point is affected by the operations at this point, because you can see that this operation will give us a carry of 1, which affects this output. So the output of this operation is affected by this operation. Since we want to obtain the whole result, we will have to make sure that we store these elements, so that we are going to store these elements as a sequence of inputs, so that we can obtain the present input operations. So let me just elaborate it a little bit more. So let's suppose you want to add these 2. So let's suppose you give these 2 values to a combinational circuit at some time t0. So when you give this operation to the combinational circuit, or we can say more specifically a half adder, it will give you a sum 0 and a carry 1. So in the next step, or I can say in the next time or some different instance of time, which is time t1, now we want to perform the operation 1 plus 1, and there is also 1 carry here. So this means that the operation, or we can say that the addition at time t1 is affected by the addition at time t0. So we need to store the previous sequence of inputs so that we can actually display it at the time when we want to display the whole result, right? So what we are going to do is we are going to store the previous sequence of inputs in these storage elements, and basically these storage elements are flip-flops, registers, and we are going to study some more type of sequential circuits which has these storage elements. We are going to study about them in detail in the upcoming tutorials, but at this point we are just concerned with why we need storage, why do we need to store the previous sequence of bits. So at this point I am going to define the actual definition of a sequential circuit. So sequential circuits are circuits in which the present output is affected or you can say the present input signals or you can say the present output is affected by the past input signals. Right, so if we want to obtain the present output, we are concerned with the present input signals. So when the present output is affected by the past input signals, which are these one, so we need to store these past input signals in some storage device or a storage element so that we can pass the output of these past input signals to the next present input sequence of bits to obtain the present output. And present output just basically means output at some instance of time. So we need to introduce some storage element so that we can store the past input signals, since these past signals will affect the operations in the future. So we will store them. So when we are going to proceed with some more operations, we will observe that we need to change the data in these storage elements. So since we want to change the data stored in these storage elements, or we can say that we want to override the values in these storage elements, we need to have some mechanism so that it will change the data in it, and that mechanism is known as clock pulse. So a clock pulse or a clock is basically just a signal. It is basically a signal when it goes from 0 to 1 or from a low voltage to a high voltage. It signals the storage elements that now you need to change the data or the bits according to the operation performed. So whenever this clock pulse or this signal changes from low voltage to the high voltage, it signals the storage elements like flip-flops to change the data. You will understand the use of clock more when we will study about the flip-flops, and we are going to do that in the next tutorial. So when we are using a clock, we are actually changing data stored inside the storage elements after some instance of time. So when we make use of a clock, then we call these type of sequential circuits as synchronous sequential circuits. So basically sequential circuits are combinational circuits plus storage elements which are used to store the past input signals which affects the present output, and when we are making use of a clock to change the data inside the storage elements according to our new values or the new input signals. And we can see that it works like this. When the voltage goes from low to high, it means that the storage element or the flip-flop will have to change the data. And then after changing the data, it will provide it again to the circuit, which is the combinational circuit, and then this operation goes on and on. So the introduction of clock makes the sequential circuits asynchronous. So basically sequential circuits means it has a term sequence, and sequence basically means sequence of inputs or the sequence of input signals. So I'm going to write here sequence of input signals. So those sequential circuits which does not have the clock pulse are known as asynchronous sequential circuits. So this is basically just an introduction of the sequential circuits, where we have discussed why there is a need to introduce the storage element. You can see that in its formal definition. And now we have also discussed about the use of a clock. It's basically a signal that says or that signals the storage element to change the data accordingly to the new operations that are coming up inside these sequential circuits. In the next tutorial, we are going to study about flip-flops and the different types of flip-flops, so that we can actually study how these sequential circuits store data and they actually act on it. So that's it in this tutorial. Thanks for watching. Make sure to like and subscribe our channel. If you want to if you want to surf or navigate through all of our courses, you can go on our website or you can download our Android app. And if you have any questions, you can ask them in the comments below. So thanks for watching.